introduction to Swift. A little bit about myself. So, Swift is a year and a half old at the moment. There's been two major revisions to the language, version 1 and version 2. A lot of people have been working on pure Swift projects for a while. I've been looking at it the past couple of months, so I'm in a mood on this. So what I'm doing is going through the language at the most basic level. I know a lot of you here are iOS programmers. Who's working on an iOS project at the moment? Show of hands. All right. So for the rest of you, it's so for the rest of you, it's a good opportunity to learn a new language. They've open sourced it recently, which means you can download the tools on Linux and run a project. This introduction doesn't have any Cocoa stuff. Cocoa is the Apple framework for building graphical user interfaces, interfacing with the Apple hardware. I've got a couple of GitHub projects at the end of the slides, which I think are interesting. For example, we'll have a look later on. So yeah, let's begin. So about Swift, safety is number one. Every single slide that I'm going to go through will make a reference to safety somehow. So to build this language, it's not just for phones, it's something that we build. It's supposed to run on watches, on iPhones, on Macs. There's some functional programming stuff. Maybe at some point we'll be able to write backend Swift code. Some of the stuff people are saying is it's a full stack language. So if you know Objective-C, and we're going to be looking at a few things, safety is a big issue, and you might, after looking at Swift for a while, go back to Objective-C and think, okay, that's weird, that's not safe at all. You know, Swift wouldn't allow you to do that, it wouldn't compile it. But you know, there's method to madness, and full stop safety. Support Cocoa Touch, work side by side with Objective-C. That might be of interest to you, so it would be great if you can start a new project and go project new Swift, that's it. But most of you probably work with large scale or middle scale legacy code bases. I've been looking at this for a while, and yeah, it's kind of fun. Like it works seamlessly, and sometimes even if you get stuck with Swift, you might say, you know, if I do this, I'll do an Objective-C, and it plugs in perfectly. Single implementation file, no .m.h, and some bells and whistles, error handling, closures, multiple return values, functional programming, etc., etc. They've been working on this for a while. They probably looked at stuff like Ruby, Go, JavaScript, Erlang. They mixed and matched and they came up with Swift. All right, there's a hello world in Objective-C. 1, 2, 3, 5 lines. There it is in Swift. Nice and easy. Alrighty, so the first thing you want to do in a language is declare variables. And I've highlighted the language keyword or native types, and the rest is my own stuff. So how do you create a variable? Keyword var, your name, colon, type, and the value what you want to give. And that's mutable because it has the word var in front. If you want to declare a constant, use let. So a couple of style pointers here. You're pretty much always going to be using let as your default way of declaring a variable. And use a var every time that you think you might change something. For example, so we saw here, that's how you declare a variable, a string for example, or an int. You don't have to do that. It's smart enough to refer of types, so var version equals 3, int, let Meetup city equals Athens. Booleans, you can use Unicode and emojis, both as values of course, but also as declarations. I think you gotta be a real asshole to do that, in my opinion. Alright, so that's cool. That's easy. Variable, name, type, and value. The style, always use let as your default. Fallback environment if you want to change it down the line. Type aliases. So it's not a big deal, this one, but it made its way into the talk. It's like the type def keyword in C, but easier. A very specific way of assigning a native data type to the alias you want to make. And here's a nice example. So you're working with sound, you want to work with amplitude, you don't want to use the native type, you want your code to be readable. So you type alias it and assign it the minimum value of unsigned int 16. So it's pretty cool. Bear with me here, that's a tuple. With type alias, you can assign a tuple to a type, if that's too complicated for you. And here we can see the method overloader, which is illegal Objective-C in Swift. Pretty much do the same thing, but instead of having to pass a parameter list, you can assign a position to it, like that. One of the, everybody works with strings, so very easy to declare them. They're inferred thus. You can add a string to a string. This is the format string in Swift. So Objective-C format strings are really ugly. In Swift, that's all it is. It's like slash, parentheses, and a value in there. Collections, everybody uses collections every day. And that's how you declare them. Square brackets and a list of your elements within. Type inference, these all are the same thing. More modern syntax, brackets string, or you can use generics and have names as an array with string. Other collections, dictionary. People with iOS, that you use stuff every day using dictionaries and arrays all the time. And as a side note, I don't know who's been working with Objective-C long enough. Remember when they didn't have these and it was like, and it's dictionary with origin arrays. So that's very, fresh. You guys working with other more modern languages, it's a big deal. Objective-C programmers, pretty cool. Loops, self-explanatory. The other thing that was mentioning here is that while you can put parentheses, but nobody uses those, and you always need brackets. You can't have like a single line, and you can get a compiler. And here's some syntactic show here for number in a range. Range, initial value, 3 dots, final value. Okay, not too advanced, but some cool stuff you can do with Swift. So that's a dictionary, and that's a tuple. We're going to see what tuples are in a second. And it's smart enough to be able to map these types into these types in the tuple, and you iterate and you print them. Some array functionality here. A list of items. You can add an item. It's mutable, remember, so you can do that. And you add a bunch of items, or you can add an item to a specific index. Same with dictionaries here. The subscript operator for the dictionary works fine with the key. It's a variable, therefore you can assign a value to that key. If it doesn't exist, it's nil. Why? Because it's an option, and we're going to see that in a second. Options. Entirely new concept in Swift. Objective-C. Can I take a second and ask you, who's working on Swift at the moment? Okay. Project New Swift or legacy code base on Swift? Okay, cool. What do you think about options when you first saw them?
They were tragic because there were a lot of bugs in Swift.
Alright, so version 1
yes, since they fixed them, they're okay.
Alright, cool. So, an optional, it says there's a value and it equals X, or there isn't a value at all, only, and that's it. The concept, some Objective-C stuff, the concept of optionals doesn't exist in Objective-C, yeah? The closest thing is the nil keyword, but as you know, the nil keyword only applies to NS objects, inherited objects, not to native primitive types. In Swift, anything can be an option, and as a matter of fact, it's worth mentioning here that Swift doesn't have primitive native types. Everything is the object ID or whatever they call it. So you can work with them with every single type there is. Like it says on the third bullet point. Alright, so that's how you declare an option. You put a little question mark next to the type of the variable you're declaring. If you don't do it, the compiler might complain on you, and that's where safety comes in. It forces you to use these things. And as a matter of fact, I'll go as far away to say that in Swift, if you compile, you're half the way there. In Objective-C, that doesn't mean anything if you compile it. For example, so you work with view controllers, iOS guys, and you have your touches began, and the set comes in, and that's a set of UI touches, for example. And the only reason you know it's UI touches is because you have a contract with the API that says, look, man, touches began, it brings you a set, and these have UI touches in there. Whereas in Swift, it's going to say, touches began, you get not actually a set, an array, and these objects are UI touches no matter what. And if you try to work with them with a different data type, you get a compiler error, which doesn't happen in Objective-C. So if you're working with Swift a bit, you might find yourself going back to Objective-C and hating it a bit, or thinking, oh my god, this is broken. Well, which is fair enough, but maybe then you start thinking, okay, maybe I can write Objective-C better, or maybe I give up 100% and work on Swift. It's all good. You're not actually supposed to do this. With an optional, and only with an optional, you can check if the value is nil. Regular data types that don't have optional, that aren't optional, will give you an error here that say, no, it's not an option. This is actually taken from Swift 1.0, prior to optional binding. You say if Vedas is nil, do nothing or return, else assign that variable to Vedas with an exclamation mark. And that's how you unwrap an optional. Apparently you're not supposed to do that very much. What you can do is use optional binding. So same stuff here, dictionaries, optionals. What you do here is you say if let Veda equals cast Veda. Now that's nil, you don't enter the if loop. If it has a value, so which is the other property that options have, you enter the if statement, and you can use Veda regularly without having the exclamation mark. So that's the way of choice to use optionals. I thought I might add the guard keyword here. That's how you manage control flow. It's stylistic, so you could have easily said if this, do that, else return. but with guard usually you see it at the top of a block or some code, and it says guard, expression to be evaluated. If it's not new, continue, else do something here or return. So I don't know about you guys, I saw a lot of that when I was playing around with Swift, getting runtime errors while trying to access a non-existent variable by forcing wrapping. If statements, self-explanatory, some style here. You can use parentheses or not, you never see them anymore. Tuples, so they're pretty cool. You've probably seen them a dozen times in other languages. They're new here. They group multiple values into a single compound value. Can be any type and don't have to be the same type as each other. Sure. So here's an example taken straight from the docs. Let error equals tuple 404 status code and not found. When to use this thing? So sometimes you don't have two variables, but you don't want to declare an object. So you want something more formal, like a tuple, that works in limited scope. And that's where these come in. You can assign them thus. We saw that before with the dictionary stuff. You can print them. You can name them. And once you name them, you can access them with a dot operator. So a lot of fun stuff you can do with these sort of things. Share data structure without sharing code with symbols. So that's pretty interesting. Example. I have a third-party library that returns a tuple. And I don't have to declare at the top of my code or include in my code. I know it returns a tuple, and all I can do is say that my code is ready to receive a tuple returned by this third-party library I've never heard of in my life. And the signatures match, and it works flawlessly. I've never actually done this, but I was working to play around and I thought it was pretty cool. It's not really a pro tip. Switch statements, nothing spectacular here. Let's look at the cases. Case 1, case 2, 3, 4, case 3 dots operator, case array. No break statements required. It doesn't fall through. Whereas in Objective-C, if you didn't put the break statement, it will fall through. Or C for that matter. And you can use it on objects. So send as a text field and or my button. And so some calling environment sends you an object, depending on what the case is. You show it. Functions. Use the func keyword. Very simple function. Prints hello world. Alright, let's look at some more comprehensive stuff for functions. So how do these functions work? We always have to have the func keyword. And like in any language, you have a parameter list, yeah? And a return value. And some languages allow you to use default arguments too. And in this case, we're using all three of them. So hello world, named parameter, string, equals John. Print hello world name. So if you call hello world like that, it only prints John. Exactly, well not exactly, similar to before, we're not returning nothing now. We're returning a string, and that's how you do a return value in Swift. You have the arrow and your return value. So if you go back to this one, that would be arrow and parentheses for void. Let a string, hello world, nothing surprising there. Alright, closures. Self-contained blocks, a functionality that can be passed around using a code. And so this is pretty interesting. So if you assume that maybe these people, you know, work in this language for the past few years, and at some point in Objective-C, they said, okay, here's the concept of blocks. I get the feeling that maybe they were saying, let's prepare these people for these things called blocks, so when we throw a new language out in the wild, people are familiar with these things. And as a matter of fact, functions are closures with syntactic sugar. So everything in Swift, you know, scope is a closure. That's the following form. That's the syntax. Parameters, arrow, return type, in, and everything between in and curly bracket at the bottom is the stuff in the closure. So let's have a look at a couple of examples. Let hello say. So let hello say constant. Declare it as a closure. Takes nothing as a parameter. Returns nothing. In print hello world. If you haven't seen this before, it might take a while for you to get your head around it, but it becomes second nature very quickly. You can have a function do task that takes that as a parameter, name parameter of type that, do task, alright, classes. Every modern language has classes. Swift has no universal base class. That might mean something for Objective-C folks here. You don't have to import stuff. Like we said at the very beginning, types are inferred. And I think we really don't have to say that in 2015 or 2016 or whatever it is, but you know, here you go, automatic reference kind. All right. Properties and classes. You know, it's all stuff that you've seen. Methods, properties, and initializers. That's how you declare a property. So there's your inheritance. The cat inherits from animal. And there's your property. Okay, so description is a property, and each property allows you to override these specific blocks of code. What would you call these things?
Get and set.
So get and set, easy stuff. Maybe in Objective-C I used to use property overrides all the time, and so you can do other stuff in there. There's your scope, go crazy. Initializers and overriding. That's your initializer there. That's how you call stuff in the superclass. That's how you assign a variable. If you want to override something with the superclass, prefix it with override, variable, name, parameter list, and get in this case. These are interesting. Will set and did set. Like a will setter and like a did setter. In will set, this code block here runs, and you have access to the old value. So it's big. Mouth is big here. Did set is if I did something to it, and did set, the value here has the new value. Does anybody here use those? Alright. How, you know, give us a real world example.
Yeah, for example, if I have a variable holding a host name,
alright,
in will set, probably I would use a method to validate, for example. Or yeah, it's basically observing.
So key value observing, but built into the language.
Or
Awesome.
you can make, for example, a log entry using this. If you change a value and you want to keep a log entry of the previous value and the second and the next value, you can use this to store a log entry in another table.
Yes. And these are how you do methods in a class. So everything we said about functions in the class. Nothing spectacular here. All right, error handling. To respond to error conditions you might encounter during execution. It has a nice analogy if you read the book. It says if you use error handling, you get specific information about the cause of your error, whereas an optional, all you know is like something went wrong and you don't know what it is. Basically, the presence of the failure, like it says here. Throw a keyword at the end of the function. Do, try, catch. Not a lot of people using these, apparently. Alrighty. So, as I said, Swift, it's open source. There's a Linux support at the moment. I'll be putting this slide at the comment of the meetup. If you go to Swift.org getting started, there's some tools about how to get up and running on Linux. If you work in iOS, you have Xcode, you can start a new playground, and much easier to get started. A very nice Ray Wenderlich tutorial there, how to get up and running with Swift on Linux, and obviously no Cocoa for Linux. And I found these nice repos. So the last one is a pretty cool style guide, how to work with them, and some pretty cool open source non-OS based repositories. This one's pretty interesting. It's pure Swift. He wrote a HTTP site. Have you ever come across these? That was really nice. Nice to get up and running and get started. There we go. It's me. A couple of apps I've written there, and some social, Twitter and GitHub. Not a lot of crazy stuff on my GitHub, but some Android stuff, some Java stuff. A couple of components I haven't updated forever. I'm working on an image downloader that I might release to the world, but I always update it. So there it is. Are there any questions, or anybody want to start up a conversation about what we've talked about here? No?
Can you explain a bit more what the unwrap in options do?
Force unwrap.
Yeah, I didn't get it.
Alright.
Basically.
It provides access to the underlying value, forcibly.
I still don't get it.
The optional is like a drawer, and
Yeah.
you either have the drawer with something in it, or you have no drawer at all.
Perfect.
That's the simplest explanation.
Yeah.
That's a great
And
analogy.
you're
Yes.
trying to open the drawer and get something from it, but
Oh, so you
there's
can get the
no-
value.
nothing to grab.
So, there's either a value, yeah, that's interesting. So, what is this here? There's a value and it equals x. Or there's not a value at all. So here, it's a dictionary, and you pass in a key, and you want to get its value. And the compiler is smart enough to know that there's a very strong possibility that there might not be a value in there. And it's an optional. If you remove that, it would refer it as an optional. So since it's an optional, you can either check if it's nil or not, and do something with it. If you're very sure that the value is included within that, you can just put the exclamation point at the back. You can force unwrap it. Yeah?
The plus from Objective-C is that if you declare a variable as an optional, while you write the code, it helps you check if, for example, if you have an HTTP request and you don't know if you receive the result from the server. It helps you to know if it has a value in it, and you can force unwrap it if you are sure, if the developer is sure that there is a value in there.
Like,
Actually, sorry.
if you had Force Awakens Vader equals 5, one line here, so you know it has a value, you'll be able to force unwrap it because you know. If any other situations where you know what it is?
No, but so it really checks that the variable is defined at all.
No?
No,
Well, we had one good explanation, one not so good explanation. Anybody else want
you declare that this variable will be nullable. Only this.
Yeah.
Okay, I'd like to go back to the drawer analogy because it was
Yeah,
a
it's
great
pretty
one.
good.
So the optional says I'm a drawer, okay? I'm an optional. If I have something in my drawer, you can get it. But if there's not something in the drawer, your program will crash.
If there's not something in the drawer and you try to get it,
Yeah,
the program will
yeah.
crash.
So the exclamation mark essentially says,
Make
I don't
there's
give a
some-
fuck, I will open the fucking drawer and get whatever it is, right?
And there's nothing in there.
Right, good.
Yeah.
But you're not supposed to do this. This is like, this is pretty safe. You see this all over the place. So here's like, this is Swift syntax. You're checking for nil, do something or do nothing else. Since you know there's a value, you can definitely put the exclamation mark and assign it to that. Here, if I use Vader inside, I don't need the exclamation mark. I can use it right away because it's taken care of with, they call this optional binding.
And the fun stuff is that if you want to print an optional without unwrapping it, you will actually print the drawer as well. So it will be optional parentheses value of the optional parentheses.
Can I ask something?
Yeah.
What-
Well,
Okay. What about the properties and methods in classes? They are private, public, or how we declare them?
you have all the bells and whistles. You have private, protected, and public. Public can use by everybody. Protected by your subclasses, and private only within.
By default,
No, the
By
default
default, they're protected, I think.
the default they're internal, which means they're essentially public but only within the same module.
What are you guys working on at the moment? Is it the pure Swift? You work for? You don't have to answer. I just want to get the.
It's
ball.
just a casual game.
All right, casual game. Is it going to be on the App Store at some point? Yeah. Oh, you're working on this together. Okay, cool. All right.
I'm working on an app to measure distances.
Oh.
By putting the phone somewhere, press start, move it here, press stop, and it should say how much it has moved. But I have issues with the noise.
Okay. Obviously not using location because GPS has a
No,
10-meter resolution. Is this a trade secret? Can you?
Accelerometer and gyroscope.
Oh, okay.
Orientation.
And how accurate?
Very inaccurate. If the phone just stays in the same place for 10 seconds, it says it moved between 10 centimeters and 1 meter and a half.
Okay.
Which device?
Hmm?
Which device is
An iPhone 5 from 2 years ago. It's a year old. I don't know how much they improved the sensors.
Check the Swiss knife app, I think. It actually measures distances. You spot with, let's say you keep it here, you get the height you're holding your phone, and then you're aiming with the top line in one spot, and you tap, then you spot the other one, you tap again, and it measures through the gyroscope and the angle. I think it's
I want to ask something that was not in the presentation about initializers and inheritance, the two types of initializers. Can you explain? Because I'm a noob and I didn't get it at all, and I was using SpriteKit and I found some example and just copied.
All right. Well, I'm a noob too. Who wants to pick that one? Anybody interested? I'm working at Fantasy.
Okay.
But what's the are you confused about the designated, the convenience?
Yes, both.
Yeah, what about it? So you need to be more specific.
How do you actually use them? How do you understand what is convenience and designated? By documentation only?
No, so convenience initializer is like an alias, like you have an alias in yourself. So you say maybe the default initializer action is init view with baron A, another argument B, and another view controller C, and another something D. But this is too cumbersome, right? So you create a convenience initializer that is just init, and the convenience initializer actually calls the original initializer with the default values.
So,
do you get it?
Yes, so actually that's why you are not allowed to use the parent classes designated initializers.
Yes.
Okay.
Well, that's
All right then. Let's take a couple minute break and.
Thanks.
Thank you.
Θες να το περάσει το γράμμα της ίδια. Δεν ξέρω, άμα θες έλεξε τον χώρο.
Πάτσε στο.
Ναι.
Δεν θα χάσουμε.
Όχι. Δες πόσο χρόνο πήρε και άμα χρειάζεται. Δεν βαρά. Απλά στην αρχή. Δεν ξέρω άμα στο streaming να το έδωσω. Θα μιλήσουμε να λέω. Ναι, κομπλέ, όλα. Πήρε μια 18άρα. Πόσο έχει τσιλέ. Άρα είμαστε άπλες. Οπότε το ξαναβάζω εδώ και όταν ξυπνήσω...
Όχι, ευχαριστούμε που ήρθες. Δεν πειράζει. Κανένα πρόβλημα. Σε περιμένω και στο επόμενο, να είσαι καλά.
Τι κάνεις, του λέει, σήμερα δείχνει με τα wearable καλά, ναι, καλά, ναι.
Ναι. Πρέπει να βρεις το SKG Tech εδώ. Έχει κάπου μια φόρμα. Θα βάλεις το email σου και θα σου κάνει μια.
Επίσης, να ρωτήσω, για το κανάλι.
Τι πρέπει να κάνεις. Σε πρώτη φάση, ρε παιδί μου, το τρέχουμε, αλλά ξέρεις, αν κάποιος έχει κάποιο θέμα, να είσαι εδώ, να βρεις κανέναν, ας πούμε, ομιλητή, που ξέρεις εσύ, εντάξει, φέτος δεν έχει πολύ δουλειά. Ξέρεις τώρα, άμα βγει κανένα, να κάνεις σύγκρονες, κανένα φίλο, slides, ξέρω, basic πράγματα.
Ναι, αλλά θέλουμε κι άλλους, είναι μεγάλο.
Όχι, ήταν γενικά στο πρόγραμμα και είχα αρκετές πρόγραμμα για conference ακόμα.
Conference εμείς τώρα θα τρέξουμε το David,
Και από ελληνικές.
το Μάιο, το οποίο θα έχει φέρει στο Dubai το Καφαράκια δεν πιστεύω ότι έχει δυναμική της.
Αλλά εντάξει, τώρα είμαστε...
Όσοι είναι αυτοί και άλλοι να είναι άλλοι
Και θέλουμε κι άλλους. Τσάκος. Αλλά είναι... Καλά. Ναι, συμφωνεί. Τα παιδιά του κάνουν. Πότε γίνεις πέρα. Αυγουστό. Και εμείς 14 Αυγούστου. Ωραίο. Σώστε, ότι έχουμε δεύτερο. Θα στείλω ευχές από το Facebook είναι. Εδώ πέρα θέλεις να φύγεις. Δεν ξέρω, δεν ναι, και εγώ χάθηκα από όλα αυτά τα πάω στη δουλειά, μετά από τη δουλειά πάω στο παιδί, θα ξεφτεύτη για 8-8.30. Θέλω να το δω λίγο.
Εκεί ήταν πολύ φλάβα.
Αλλά είναι άλλη φάση.
Βλέπω ένα σταχτήρι στα πόδια. Κατιστός δεν μπορεί.
Προσπαθώ. Τον ένα στο iPhone και το παίρνω. Καλό είναι. Κατευθείαν. Σπίτι μου σε καλό. Σου λέει μήλο. Δεν το πάω. Ναι. Τώρα το βράδυ ξέρω είναι να σε πάθει μάλλον το φτάνει είναι τόσο φυσικό. Έτσι να χρησιμοποιήσεις καιρό συνέχεια. Όταν πήγαμε στην τάξη και είδες πως συνέχεια είναι θέμα τώρα. Εντάξει. Ναι. Τι έκανα. Πλάκα. Ναι. Το λέω σου πλάκα. Παντελής.
Το βρήκες.
platform.
Μισά ελληνικά, μισά αγγλικά.
Platform is το πλάσμα. Dat dan een klassiek komt.
Ναι, καλύτερα να κάνουμε κατηγορία στο αυτό.
Πάντως, το brainstorm πρέπει να παίξουμε σαν διάφορες ιδέες. Ναι, πιάσουμε άλλες στιγμή, ξέρει ότι θέλω να τάπω κάτι σαν το τάπω.
Κάποιοι πήγαιναν στο χάλι.
Είναι και άμα δεν το κοιτάξεις, μπορεί και να παίξει το μετά.
Τώρα και πολύ λίγο έτσι.
Τι σκέφτεσαι τώρα. Πες ότι πάω να δείξω κάτι όσο τέλος μιλού. Κάνω αυτό και είναι άλλο.
Αυτό το κάνα και στάδια, δεν είναι κάτι έτσι να είναι κάτι κατάστατο και...
Στην αρχή που μέχρι να τα καταλάβει λίγο για να μπει στο τέτοιο, ειδικά στην αρχή που είχε bugs, που ξεκίνησε από το κάτω να το κάτω σε Swift, και μετά έφτασε σε bugs στην Swift. Το παράτησα και τώρα ξεκίνησα από δεν τα φτιάξω όταν τα σε δώσω σώπες. Αλλά κάτι προσωπικά έτσι mini projectάκια που
έχει ωραία πράγματα.
Για να μαθαίνω να μην αλλά όσο τα δούλευα, έβαζα ένα update στη Swift, σε όλο το project, όπαιζε. Δεν κάνω migrate το update και θα το φτιάξω. Αλλά κάποια στιγμή, ας πούμε, κάτι το ένα πρέπει να το και μετά. Στη 2 βασικά, έγινε το κάτι στα bugs. Μετά να σου πω την αλήθεια κατάλαβα και πώς λειτουργούμε στο τέτοιο και βοηθάει. Ενώ στην θα κρασάρει, ας πούμε, θα το έχει σαν bug fix. Ενώ εκεί σου βοηθάει, εσύ ναι, ναι.
Κάθε φορά που φέρνουν να bytes, κάνει και ρωτάνε να και λέει ανέβουν τις bytes. Και αυτό μας είναι ότι πάλι σε ένα όσο και το στέλνει. Και αν έχει ένα κλάσι να πει εκεί, αλλά δεν θα σου μάθει αυτό γεύσαμε. Α, πρώτα εσένα στο ευχαριστώ.
Τώρα τη βγαίνει μια τσάπα και παίζει ένα MacBook,
Τράει κάτσε.
Οπότε παίρνεις αυτό το multi-part entry και παίρνεις το blocks. Από εδώ πέρα παίρνω σε ποσοστό και κάνω πώς θα είναι το θεσμό. Από τι γίνεται. Και τώρα έχω τα bytes εδώ. Και μετά παίρνω σε various errors και κάνω post notification και ζητάει. Και όποιος είναι κάποιος ακριβώς, συνήθως κάποια ακόμα. Τώρα το retrofit τι θα κάνεις. Αλλά δεν σου ότι κάνεις στην αρχή. Δεν θα το πω λίγο. Όχι, δεν το καταλαβαίνω.
Πώς δεν είναι
δεν το
Εδώ είναι. Έχει 20%.
Ναι.
Να το πλακάρω.
Να φτάσει.
Όλα έχει το νους να πατήσει το start και να μου πεις άμα είναι στο πλάνο, ρε παιδί.
Trust. Βάζω να το trust.
Ναι, ρε. Α, έτσι είναι
Τίποτα εσύ. Α, αυτό είναι. Δεν πειράζει.
το πονάτο. Πήγε ρε.
Okay, so on to the part 2, testing iOS application. And this is ironically called breaking the taboos because, you know, testing is a taboo because no one does it, no one admits that he doesn't, and no one wants to speak to anyone that he doesn't. So the obligatory, pre-talk poll if you want. Who supports an application on the App Store right now? Hands, please. 1, 2, 3. Okay. Who tests this application that is on the App Store? One. Say my app. Hands. Okay. What this talk is about, and this is our agenda. A high level, an overview of what is testing and why you should do it. Configuring Xcode and the whole, workstation for testing. We'll see an overview of what's the current state of testing frameworks, open source testing frameworks that you can use, whether you're doing Objective-C or Swift. We will speak about Nimble, which is actually a mature framework, Swifty mature framework, and I really like it, and I use it, and I will explain it to you. We will also talk about Okay, we'll talk about exit test, which is the default kind of testing framework that Xcode finally ships with, because back in the days with Xcode 4 and etc. You didn't have a native testing framework with Xcode integration, so you might have an excuse of not doing your tests back then. We will talk about testing view controllers, which is really, really important, because view controllers is actually what your user sees at your application. We will see some pitfalls and some bad practices that you might come across while you're doing your tests. And we'll talk about some issues that we might see at the future meetup here. Okay, first of all, what is testing? Well, tests are obviously code, and this code actually runs, or if you want, utilizes your current app's code, with the utter goal of making sure it behaves properly. And one might ask, so what the hell is properly? Well, taking into consideration that the academic term for an algorithm is something that takes input and produces output, tests actually test that your code behaves properly in the form of taking specific input and always giving you the same output, as well as when stuff goes wrong and you give him fuzzy input or illegit input, it behaves properly and it doesn't crash to hell. There are lots of, actually not lots, there are kind of 5 type of tests, and I'm going to list them here ordered by magnitude if you want. So unit tests are the smallest possible kind of test. They test one method and that's all, okay? One level higher we have integration tests, which might test more than one methods at the same time, or even a whole module, or even 2 or 3 modules together, okay? We have, of course, user interface tests that basically operate on the presentation level of your application and tests actually perform in an automated way what a user might perform on the application. And we have performance tests that might fully stress test your application by calling several methods and several intense functionality many times in order to see how they perform in terms of CPU, memory, and time constraints. So as you might have already understood, unit tests are cheap. They run fast. They test kind of small ranges of code, and performance tests, because they utilize as much of your application as possible, they are quite expensive. So why you should consider testing, and especially if you're doing gigs for a client, or especially if you care about your application and your reviews on the App Store. First of all, testing forces you to write better code, because you will see that when you start testing, you will come along some of your current code that there is no apparent way for you to test it. So if you start by writing your tests early, it will put you along a track that will force you to write cleaner and more compact code, so it will be more easily testable. Of course, tests ensure that you ship less crapper to your clients. There are significantly less bugs and less, crashing situations because you supposedly test everything. Your technical debt diminishes, and this is something that your CDO or technical manager might like very much. Of course, if you have a certain level of code coverage in your current code base, it allows you to further progress with implementing new features with confidence, because you're sure that whatever you have written right now just works, and I can safely go ahead and write new stuff without having to worry about something breaking up. And regressions is basically the same thing. It means that if you discover a bug and you go ahead and write a test for it, you make sure that it will never happen again. That's a regression. Okay. So, compulsory academic references. Tests should be first. We are engineers, we like acronyms. Here's another one. First. What first is that your test should be, first of all, fast. That means if you have a test suite that takes like 5 hours to complete, you will not run it as frequently as you should. So some bugs or some problems might actually get shipped. Your tests should also be isolated. And essentially, what does that mean? What that means is that your tests shouldn't depend on state that was created by a previous test. So, for example, if you're writing tests for a cache manager and you want to see if there's something in the cache, you need to make sure that prior to any test running, you should clear the cache, right? Your test should be repeatable, which essentially means that even if you run them 10,000 times, you will get consistently the same output as long as your original source code wasn't changed. So for example, if you have written some tests and although you haven't touched anything in your original code and 10% of the time some tests fail, you have a problem. Self-verifying actually means that your test actually asserts something, which means that they actually test the result of something instead of arbitrarily coding code. I have read some anecdotal blog posts about companies outsourcing the burden of testing their software to another company, and the other company went back and said, okay, we have 100% code coverage, which means that their tests were actually calling all of their code, but most of them were not asserting anything. And they just saw this 100% number and said, oh, hooray, we have tests. No. And timely essentially means that you should write your test as soon as possible, and even better before you go ahead and write your actual code. And this is actually called test-driven development. It's a practice that you might like it, you might not. But it is a good idea because it again forces you to think of how to write better testable code, and testable code, besides being testable, is also more compact and more easier to understand. So what I'm gonna do is I'm gonna take you hand by hand, by the hand, so you have absolutely no excuses whatsoever from now on to start testing your applications. So, Xcode is kind enough to include a testing target by default. So please make sure that you check this button if you want, testing coverage in your application. Checking that button essentially means two things. You get a testing target, which is this one, and you get a testing bundle, okay? Now, if you currently have a project and you've been naive enough not to test it, you can still do it. Don't worry, it's very easy. You actually navigate to your test navigator. You click that little sign icon down here, which in my opinion should be a really big red button. and you click new unit test target, and boom, you get the information which target to be tested, and you get again the testing bundle and the new testing target. Now you have the most primitive setup to start testing your code. What do you need to know next? It's nice to know because testing what happens is actually it builds your application like it would be in a normal situation. It lifts the whole stack, which means it lifts the simulator, and then it starts performing tests in an automated manner. And because you want your tests to be fast, like we said before, there are some occasions that you want to know whether your application is being run in testing environment or is being run in production. And actually, in order to know this, there are 4 ways. The first way is to know that you're in testing in compile time in the form of preprocessor macros. And the other 3 ways, please. And the other 3 ways is in runtime. The first way is with launch time arguments. We will see what is this. Processing for environment, and the Objective-C runtime, which is also shared in Swift. Okay, the first one, in compile time. What do you need to do? You navigate to your project structure, okay? Here, make sure you are in Info tab, and you go ahead and duplicate the debug configuration, okay? This is, you've probably done it before. And what you want to do is filter here with pre-pro or preprocessor macro if you want to write the whole thing. And you click here and add this testing equals 1, okay? Simple. And then, in your application did finish launching or pretty much anywhere else, you can have a preprocessor macro that says if not testing, do this and if. And why this is useful? For example, if you're testing, you might not want to include proselytics. You might not want to log as heavily as before, and other stuff. Runtime. You press Command and less than on your keyboard. You go to Edit Scheme. You go to your testing target. Okay. You deselect this little checkbox and add this is testing argument or whatever you want to call it. And then, boom, in the runtime, you can create this method and say, return ns_process_info arguments contains is testing, which means if I got this argument during launch, I'm in testing environment. Of course, you can declare it in your app delegate or wherever you want to declare your global helpers, and just use it here and there to distinguish whether you're testing or not. Now, you can also do it during the runtime by using the process info environment, because like I told you before, when you create, when you include tests in your project, you get a bundle, right? So this bundle gets injected in your stack when you fire up the simulator into testing mode. And again, by using process info environment XC inject bundle, you can check whether you're in testing mode or not. Finally, this is a runtime hack, and actually it's only applicable if you're using XC test framework on Xcode. And what it does is that when you're running testing mode, the XC test case gets injected in the runtime. So if you call this method and see that it is injected, it means you're in testing mode. Simple, right? Okay. Now, testing frameworks, there are quite a few. Essentially, they come in 2 flavors. Actually, they're not flavors, they're categories. You have BDD and TDD frameworks, which are actually how you write the specs. And you have the matchers, which is actually how you assert that something is equal to something or something is not equal to something. So in terms of BDD and TDD, you have XE unit, which is the default of Xcode. You have Spectre, quite significant contributors in this project, Facebook guys, GitHub guys. You have Kiwi, which is, lots of people are using it. Spectre and Kiwi are quite similar in fact. You have Cedar, which is another one from Pivotal Labs, I guess. And you have Quick, which is also maintained by a Facebook guy, and it's actually a pure Swift testing framework. One of the very few, and quite possibly one of the most mature. Now, in terms of matchers, please. Again, you have XEUnit because it comes with its own assertion macros. You have Expecta, which is, if you want, the sibling of Specta. It's written by the same guys. You also have Nimble, which I'm quite fond of. It's again purely Swift. And now, how do you come to choose a testing framework, right? First of all, in order to choose your this BDD means behavioral driven development, and TDD means test driven development. The difference between the two is that in BDD you write your expectations kind of like in natural language. So you say describe my view controller. It should create a pop-up when I click this button, and then you assert this test. Okay. So what you want from these frameworks is, first of all, you want to have good Xcode integration, which means you want to hit Command T, and you want Xcode to bring up the whole stack utilizing that framework, and having the reports ready for you and all that, candy. One thing you might also want to consider is how close is this framework, the specking of the framework to your requirements. So you might be part of a big ass corporation that have a separate quality assurance test, or your CEO might be the one who does the quality assurance. And BDD helps because the CEO writes the specking, like we said before, in natural language, whilst on test-driven development he has to write functions and classes and some classes and stuff. You might also want to have mocking and stubby support. We're gonna talk about what mocking and stubbing is probably in some of the next meetups. And from matchers, what you want is to have a convenient domain-specific language, because what these guys have done is that they have taken the bare bones XEUnit assertion macros and transformed them into natural syntax that you will see in a while. This is very important. You want your matcher to have asynchronous expectations. So, you might have an asynchronous expectation when you make a call to your backend and you expect a result, and you need to test this in an asynchronous manner, so your matcher needs to support this. What I like as per January of this year is bare bones XEUnit for BDD, for TDD actually, and the Nibble matcher framework, which is the sibling of Quick. And I like them because, first of all, XEUnit is the native thing. It has the greatest Xcode integration. Its harness is very flexible and bare bones. You can do whatever you want with that without having any constraints. It kind of looks fast so far, so I have about, it should be around 200 right now, and they usually run below 15 seconds. And Nimble, as you will see in a while, has great built-in functions and very, very expressive DSL, domain-specific language. So, Nimble, the fundamentals. How Nimble works, it has three parts, right? So, you have the actual value that you want to test. This comes first, and you express this in code with the expect function, okay? And then you have the operator, which you chain to the expect function, and usually this operator is to, not to not, and there are some others. And then you assert that the value, the value that you're expecting is the one that you expect it to be. I know that doesn't make very much sense, but you will see in a while what I mean. So you would have like expect my var to not equal scatter, or you know expect my flag to be true. So you kind of have this thing going on. So you can, you know, expect values to be equal with something, expect values to be less than something, expect a button to be an instance of UI button, expect a string to be a kind of string, expect flag to be true, expect my array to contain Coco, expect my URL to contain HTTP, expect my URL to end with .io, expect my array to have count 10. So you use this domain-specific language in your testing functions, and if, for example, something doesn't pass the assertion, so if this flag is false, the test fails and you get a notification in your console. Of course, you can use the normal operators, so you can actually say expect actual equals expected, expect actual less than expected, etc. It's quite simple actually. And if you want to go further, it has support for C primitives, so CF string and that kind of APIs. It supports lazily computed values, it has async expectations, although they don't work very well. It has error handling, you know, assertions for throwing, what Dimitris described earlier. You can write your own matchers, which is quite convenient to have, you know, complicated stuff going on. And you can have custom failure messages, if that helps you to, you know, log some variable or something. You can read the manual on the GitHub repository that they maintain. And now onwards to exit test. So what we saw earlier is Nimble, which is the matcher, and now we are going to see exit test, which is the native TDD framework of Xcode. This is the generic structure of a test. So first of all, using the testable keyword, you import your whole application into the testing suite as a module. Your testing suite starts by subclassing XCC test case. So whatever is in this class are your test cases. Each test case has a setup and a tear down function. The setup function gets called every time before every one of the testing cases, and the tear down is called after each of the testing cases. Okay. Now, whatever function you have declared in this subclass and that starts with test, it's actually a test case. So the XCC test framework, you know, runs during tests. Of course, you could have helper functions that do not start with tests, so you can conveniently use them to manipulate data structures or whatever. So a very simple example with XCC test and Nimble combined. We have imported our application as a module into our testing suite. We declare in the higher level of our scope a variable named calc, which is actually, you know, off top my calc, whatever that means. We initialize it in setup, which means that it gets initialized, it gets a fresh instance before each test case. In tear down, we make sure we clear the cache, whatever that means, just to bring it in the neutral state, because like we said earlier, we want your test to be isolated. And this is actually a test case, which says, you know, take this helper function, which is not part of the test case because it doesn't start with test, generate two numbers, and then expect the add function of calc, you know, to actually add the numbers properly. Okay. Very convenient shortcuts. It's good to know them. Command U executes all the test cases in your suite. Control Alt Command U runs all the cases in the current file that you have open, and Command 5 opens up the test navigator, so you get all your test cases and a check if they pass or an X if they fail. Now, you might be kind of the console guy, and you might like to run your test from your console. There are two very convenient tools. One is Exitool, developed by Facebook. It actually is a wrapper for Xcode's cell commands, and it pretty prints all the results, and you can also, run your tests in a very easy and convenient way. You can install Exitool using Brew, and Scan, which is a very interesting tool, and it's part of Fastlane, which is a very interesting suite of tools, and hopefully we're gonna have a meetup covering most of these tools. Again, it's just a command. You can skip this whole thing. It will derive your current scheme and your testing target, run your test, and give you, pretty output and all that jazz. Of course, with Xcode 7 and something and beyond, we also have testing coverage data, which means that every time Xcode runs your test, it produces a report that says how much of your code is covered by your tests, and precisely which paths were called, which methods were called, and in order to enable you go to your testing target and make sure you click the gather coverage data. And if you do this and you run your tests, you will see that in your main editor, you get these red things right here, which says this part of the code was never tested. And for example, there's a 4 here which says this part of the code was regressed 4 times during your testing. Okay? Of course, if you go to the report section of Xcode, after you have run your testing suite, you get a fully fledged report of what actions were tested during the test process, how much of your application has been tested, which functions and to what percentage have been tested, and all that useful information. Please don't fall in the trap of writing bullshit just to fill this bug, okay? Make sure you actually assert something, and make sure you always remember that silly company that outsourced the testing thing and got shit back. Now, testing view controllers. Very important because, like I said before, view controllers is what your user end up seeing when they run your application. So you really need to nail them. They need to be solid. You have to test the crap out of them. Most people think that it is impossible, but it's only impossible if you make those big ass fat view controllers that we all used to do. So you have this view controller that has a collection pool and maybe a table view, and you have all the data source and delegate methods in the same file, which is in the view controller. Please don't do that. It really helps if they're pretty thin and you decouple delegation and data source to other files. Whoops. Okay, so many people might want to counter-argue why would you want to test your view controllers whilst the cool guys from Apple gave us this new UI testing tool. The reason is that the UI testing tool is slow, because like the simple testing process, it has to bring up the whole stack, and then what it actually does is like having a robot clicking on stuff on the simulator and kind of simulating what you want to do. But it is definitely a good start because they are easy. I mean, you open Xcode, hit record, and then do stuff on your simulator, and you get automatically generated code that you can kind of edit and tinker with and just bring it to where you want. But they are super slow, and you could always do it the bare bones way, which is faster and more versatile. Yeah, so we talked about that. In terms of the testing categories, I would say that testing view controllers kind of falls into the integrated-ish tests. So they are not unit tests, they're not performance tests, they're somewhere in between, because they combine both, simple compact methods of the unit test and greater modules and delegates and data sources of collections. you should also make sure that you test whatever dependency they have, as soon as it's your dependency and not an external library. We're gonna see this in the pitfalls in a few. So how do you do it? What do we need, right, to test a view controller? First of all, view controllers have life cycle, and this life cycle begins with view did load. So you already know that most of the bootstrapping and initialization of your view controllers takes part in that view did load part, right? Occasionally you want the whole stack, which essentially means a window, so you can push and pop view controllers and test, storyboards, logic, or whatever. You need to be able to reference IP outlets and treat them as a user would. And you usually want a way to detect state and hierarchy in your view controller. And by state I mean, did another view controller got pushed, or did a UAlert controller got popped, whatever. So, one by one, triggering view did load, boom, very easy. The only thing you have to do is access vc.view. So you initialize your view controller in a variable. This underscore here means that I don't care what this is because I'm never going to use it, and the compiler doesn't, doesn't bitch about it. So what this simple thing does is that it actually triggers view did load, which is awesome because all the bootstrapping code that you have gets run. Unfortunately, no lag for view did appear or will appear, or did hide or will hide. So, bummer. So, what if you need a stack, or if you want to load stuff from your storyboards, or you need the basic foundation of pushing and popping stuff from your view controllers? We have a case with a storyboard here, so you initialize your storyboard in some variable. Okay, you instantiate view controller with identifier, that thing that you have registered on, interface builder. You get a reference to the delegate, because what the delegate has is, it has always a window, right? And the window is the most privileged thing that you need in order to display UI to the user. So essentially, this is the stack that you need in order to perform, push and popping of view controllers and other stuff. And so what you do is you initialize this window, you set a root view controller to this, in this case a navigation controller, and you make sure that you call make invisible. Okay, and then by using the same trick as before, you essentially have now the whole stack that you can use in order to test what we talked before about, pushing and popping view controllers or detecting state. This is very useful because view controllers have most of the time some outlets, and most of the time these outlets are buttons, and when you tap those buttons, something happens. Of course, the naive way would be, in your test case, you would just go ahead and call the selector, call the selector of the button, but this doesn't ensure that actually the IP outlet is connected with an IP action, right? So what you want to do instead is, of course, assert that the IP outlet, in this case logout button, is of type UI button, and then by using this nifty little method, send actions for control events that start inside, is like saying I'm a ghost and I want you to tap this as if I was a user. And this is also ensures, like we said before, that the IP outlet is actually hooked to an IP action. Of course, IP outlets are most of the time public properties of the view controllers, so you can easily access them in your test cases. Now, when you want to test hierarchy, right? And by hierarchy, I mean if a new view controller got pushed, probably as a result of an action, or if a UAlert controller or a pop-up, got displayed again as a result of an action. So, up until here, we've talked about this is the whole stack. This is triggering view did load. We use this nifty method to call the selector of the IB action of the IB outlet. And let's assume that the action is to present an alert controller, and then we assert that, expect VC presented view controller. So, okay, I started with that view controller. What is presented right now? This property holds this to be an instance of your alert controller. Okay. Now, some pretty obvious, well, they're not obvious, but they're established bad practices. There is a tendency to write tests that kind of fall right here in the middle. So they are not unit tests, which is good to have. They are not integration tests either. So there are these dirty little hybrids that, test more than they should and less than they should. So don't do it. Another bad practice is giving your test cases shitty names. And it's a bad practice because the names of the functions that you give to your test cases are what is getting dumped in your console when a test fails, right? So for example, if this dog instance didn't have brown color, you would get test color failed. And good luck knowing what the hell this is if you have 500 test cases. So this is bad, and you should give ultra descriptive names to your test cases. So test German Shepherd dog breed has proper color, or even test German Shepherd dog breed has brown color if condition. It's not bad to have this, okay? You need to be explicit. Another bad practice is feeling the urge to kind of test private methods. And I mean, private means private, right? First of all, you cannot access them from your test cases. And for that reason, you kind of have the urge to change them from private methods to public methods in order to just being able to test them. This is utterly wrong, and if you feel the need to test a private method, it means that this private method is doing a lot more than it should be. So it's not a helper method to your to the rest of the API, but it's rather something, dinosaurs, as we would say. So what you should do about it? The first thing that should come to your mind is refactor it. Okay, if a private method is not compact and doing just one thing, you might need to rethink the way that you want to write this logic in your module. Actually, the best way to test private methods is to do it through the public API of your class, because essentially that assumes that the public API kind of utilizes the private method down the way, so it gets called in one way or another. And if you have such a big dinosaur role that you cannot do any workarounds, you might want to dump it in a static class, create a very strict contract of what other classes should be able to use that static class, and test it that way. Most people that haven't have much experience with tests, including me, at least until recently, have this tendency to couple their tests with implementation details of their code. And this is bad for lots of reasons that, I mean, it could be a 1 hour discussion, but you should at least keep in mind these 3 bullet points, which first of all is never in your module test, so you're testing a module of your own, you should never call APIs of external libraries. So that means that if you are using Alamofire in a module and you want to do that request, you don't want to directly call Alamofire, okay? Because if you go ahead and change this library, down the road, then you have twice the work of refactoring work to change your tests back and work around this. So one possible solution here is to just stop it, okay? Which brings us to the second bullet point, and mocking and stubbing is okay, but always make sure that you test the external libraries independently in another test case. By the way, I think Alamofire and Matt Thompson is kind enough to have his own tests into the pod. So yeah. And constructors are also implementation details, and they shouldn't have, and normally don't have, any behavior. I mean, if you have logic and behavior in your constructors, this is a smell, and you should probably refactor it. I guess that'd be all with bad practices. Going further, if you want to explore more things around testing, you can check out stubbing and mocking objects. And what that means is, instead of using the actual instance of, let's say, NS user defaults or NS notification center, you create a fake class that has all the helper and the sugar that you want, and you just feed it to your code and use that instead of the actual one. And stubbing could also mean stubbing network requests. So instead of directly making an HTTP call to your backend, you just create a stub, you get a predetermined response without any networking stack being used, and you continue with your testing logic, having that response already handy and available. And after a while, you might start exploring stuff around continuous deployment, which essentially means that you do not run your tests on your own, but you have a mechanism that kind of plugs on the repository, and whenever you do a commit or a pull request, it automatically runs your tests, and even deploy the application to TestFlight or Crashlytics, or even deploy the application, if it's tagged as a release, to the App Store. This is very interesting. I guess we could have a talk about it. And that'd be all. Questions? Anything?
Who is this guy?
This is Ventura. Pretty good guy. So, any questions about testing? Anything you might want to, any objections?
You said about UI testing that is slow. Does it do the test in real time? It just clicks like a user would do?
More or less, yes.
It launches the app, presses button, is using the accessibility API, so it takes as long as it takes the user to navigate in the app.
What kind of tests you need to do and what kind of results we expect?
So, for example, so before that thing, there was an instrument that was called UI recording, okay? So, what it would do is, it would fire up the simulator and would say, click whenever you want. And you would click, in text field, you would type your login, you would click another, you would type your password, and then you would click, login, and then you would get another screen, okay? And this would get translated in kind of something between if AppleScript fucked JavaScript and had a baby, something like that. But then they figure out this is an accessibility hack, so you get native Swift code, but it's still as slow as kind of having an ultra fast robot.